Thanks, Andrew. If people weren't awake before, I suspect they are now. So we're going to turn now to some of the policy issues, and Steve Goodman, the Associate Dean for Clinical Translation Research at Stanford School of Medicine, is going to talk from the perspective of research funders and publishers.
Hi. So yes, I'll be talking about them. I'll also be talking about academics, and you will see that there might be some question as to whether Andrew and I coordinated, but we didn't. We're just on the same train traveling somewhere. Let's see, how do we do this? Okay, there we go. So actually, I'm going to be talking about not just about journals and funders, and I'm going to be talking about this thing called reproducible research. And I haven't heard that word used today. That is the dominant word that's being used in the biostatistical and bioinformatic community, and I'll talk about why. Also, you'll notice I changed my affiliation here from Stanford to the two journals that I work at, Annals of Internal Medicine and Clinical Trials, and why is that? Well, first of all, just telling you what some of my experience is, but in fact, journals themselves represent, there's a conflict of interest for those that are not what's called open access. I actually don't like the term. I say open access for who? I say that the journals who will accept without charge a submission from anybody, that's open access too for the contributors. So it's just a question of who pays and how the money flow goes. But for subscription-based journals, you don't get free, not everybody gets free access to their content. They hold it back because they have an interest in it. And it serves another interest. I mean, it enables them to have editorial staffs and add value, and I believe it has added value. And that's the same kind of disincentive that Andrew was referring to when he talked about the incentive we need for people to produce data in the first place. If they're going to spend 10 years running a trial or whatever, if they're just going to hand it over to somebody else who's going to produce their papers in 6 months, that's a huge disincentive. So these are real things, and they result in value, but they also result in a disvalue. And how to balance those, I think, is one of the real challenges. Now, there actually was a conference here on this almost exact topic 9 years ago. I participated in that. I wasn't on the panel. I talked there. And they endorsed something called the upside principles. And I'm not going to read through these, but it could be an exact mirror of what we've been talking about today. These upsides stand for Uniform Principle of Sharing Integral Data and Materials Expeditiously. I don't know which they came up with first. But it's really a wonderful document, and it includes a lot of excellent suggestions for how data should be shared from the perspective of the publishing community and the scientists who generate it. And these upside principles are formal principles that have been endorsed or not by a variety of other groups. So I would encourage you strongly to look at this document because it presages a lot of the things we've talked about today, although there's been a huge amount of cultural and technical change since then. So let's talk about some of the purposes of data sharing, and I'm going to focus on a purpose that actually hasn't been the main focus here. First, it's to discover new things, and that's been almost the dominant conversation. But the second is to assure that the study was correctly analyzed and interpreted. That is, to provide assurance that the chain of scientific custody from protocol to conduct to data to analysis to published result is sound. And I've often said, sort of, if we could see under the hood of what's going on in the analysis of a lot of studies published in major journals and minor journals, we would just blow the top off of science. It's unbelievable what a mess it is. It's a huge mess. Only the major journals have sort of teams of methodologists that can even begin to check this, but it's hugely challenging. And the journals that go right below that tier, really very little. I mean, they depend on peer reviewers. Peer reviewers are totally powerless. And why? So here's an example why. This is a study called the CAMP study, Childhood Asthma Management Program study that was published in New England Journal. And these slides are courtesy of Jim Tanasha, who is a PI on this study. And there's nothing wrong with the study, by the way, I'll tell you that ahead of time. I'm just going to show you what went into the study. And here we go. The number of separate forms they used for the study, 72. Number of form revisions, 109. Number of data entry forms, 41. Total forms in the database, about 300,000. These are the number of transactions in the database, 35,000 changes, 4,000 deletes, about 330 total transactions, and it said 200, almost 300,000 total forms. In terms of the actual manuscript, originally it started with 73 tables and 9 figures. There were 40 revisions. What was published? 3 tables and 2 figures. And this was published in October of 2000. Now, how do we begin? How do we begin from this tiny little slice that we see to begin to work backwards and figure out, well, is what they did right? And it's this sort of thing that I think that folks were talking about when they talk about the complexity of sharing what was really done in many studies, even though I completely concede that for many studies I've done, they're as simple as Andrew described. So what was the result? Well, the result is this comment that was actually made by a computer scientist who started the field of reproducible research. He said most published papers are an ad for the research rather than a real report on the research itself. And it's absolutely true. Now, with supplementary materials and appendices, this is changing, but we still can't get to the heart of it. We just can't get to the heart of it. So there was a paper that inspired our thinking at Annals about how to deal with this, and there's a lot more to the story than I'm going to have time to tell you today. But this was a story on this topic. Do Oscar winners live longer? Now, you might wonder, why does the Annals of Internal Medicine, why are they interested in this? Now, most of the patients of our readership are not in the running, but it was published. I would say we were a little uncomfortable with it. It claimed that there was a 4-year survival advantage, and any of you who watched the Oscars have probably heard this claim every single year. It's trotted out, and you'll hear it again this year. And I have to say we were pretty skeptical about it, and there's, again, a long story. But we actually asked the author if he would publish the data set publicly upon publication of this, because we wondered about it and we want to know what was under the hood. He did for 1 day. It appeared on the day of publication, then disappeared, he said, for reasons of confidentiality. I don't know if the Oscar winners are so worried about confidentiality, but in any case they did. So, but this is what happened. This is how he explained the possible 4-year advantage. Personal chefs, trainers, nannies support ideals of lifestyle. Constant scrutiny and entourage invested in the movie star's success leads stars to, quote, avoiding disgraceful behaviors and maintaining exemplary conduct. Well, I actually had to remove the few slides I had showing the exemplary conduct of some movie stars because I didn't think it was fit for this august institution. But let's just say that doesn't always occur. But anyway, there was another statistician, Jim Hamley, who was a little exercised about this because he didn't believe it, and he wanted to get the data set. He tried. He was not successful for 5 years. He finally got an amended version of the data set because the author said that they had lost the original one or couldn't find the original one. So he got an updated version, and he was convinced it was misanalyzed, and in fact, I would say that it was. And he published a very detailed explanation of why and how to analyze data like this, and he came up with this result, an estimated life expectancy difference of 0.7 years with a p of 0.16. And thereafter, I and the editor published a little mea culpa about how it happened. But he says, of course, readers and commentators should be doubly cautious when they encounter statistical results that seem too extreme to be true. And we published this because we thought it was an important corrective. First of all, it was a very important methodologic point about how to do this. It had to do with immortal time bias. But it taught us a lesson, and we think about this a lot. And there was another paper that was actually published the same year that gave us the tools. It was this paper called Reproducible Epidemiologic Research. And this was by 3 colleagues of mine when I was at Johns Hopkins, where I was for 20 years until last year. And they talk about the research pipeline. Again, this was derivative from prior work in this area of reproducible research. And this is sort of bringing it into the life sciences realm. It really was in the world of computer sciences and computational sciences, where the models were so complicated that even if you had the model, it was very difficult to figure out if you had it right. So just having the model, some of these economic models, I mean, you can't figure out from looking at them if what they did was reasonable. I mean, and that's a situation where you have everything laid out in front of you. So here's the pathway, and actually you'll see this is, from biostatisticians, at least it starts with the measured data. Of course, we're interested in a lot of things that come before the measured data, but the article is at the end. But we want to shine a light at least on this middle part, the analytic data and the computational results, because it's not a given that will produce the results that you see. And so part of what you want to do is that. But the other issue that they brought up here is sharing models. And right now, the models of sharing is you share or you don't share. And they introduced the idea that, well, here, authors put stuff on the web, supplementary materials, or some central database, and the readers just download the data and figure it out and get the software and run it. That's the current model. Well, they propose two other ways to do sharing. One is that there are all shades of gray between the share and the don't share. I think this is extraordinarily important. The dialogue so far has been a little bit impoverished because, and I think John Wilbanks and Devin McGraw coming after me may address these issues, that there are ways of sharing, and we do it all the time when we use intellectual property of many kinds, that don't involve complete free use of what you get. And so here are models. The data can be used for purposes only of reproducing the results. Share alike. It can be used to produce new findings or results, but any modifications to data, including transformations, et cetera, have to be made available under the same terms. Or maybe you can't publish without the co-authorship of the people who provide it. Attribution. Data can be used for any purposes with authors cited. Full access can be used for any purpose. And these are contractually mediated. So I'll look forward to the discussions after this. And I'm sure there are other shades of gray. The point is there are ways to mediate this relationship that are not, I give you the data, I don't give you the data. And maybe we're going to have to start working on that. The other thing they talk about in that paper, which I'm not going to be showing you today, is the new form of producing reports through software called SWeave, which are dynamic reports, and it's incredible to see. It's not just results on paper the way we see it now. The code is woven into the paper, and the data sits behind it. And for example, if you change a single point of the data, it ripples through the entire document. All the figures change, the analysis change, the tables change. So this is what we actually have right now. And so everything is transparent. You have the data, you have the computations built into the paper. So that's another way of addressing this issue about the issue of just downloading the data and sharing it. The code and the analysis is already built into what you get, because those actions are very difficult. There's also a lot of different data sharing structures, and this was not in that paper, but I just want to point out we talk about, we don't make these distinctions. There's of course the dyadic, the researcher and the person who wants to use it. There's the institutional way of handling it, where we have central repositories, and then we have the study-based ways of handling it, like MESA or Framingham or the Nurses' Health Study, and then of course we have this new model that's being developed, the nonprofit institutional open access public data sharing, and we've heard Dryad mentioned. We haven't heard iDash. Dryad, as I understand it, it was built for the life earth sciences, but Dryad, iDash, supported by I think it was ARC or NIH, is specifically for health research, and they have developed not only automatic anonymization, you'll see up there, integrated data for analysis, anonymization, and sharing, but and this is going to be very, very critical to a proposal I'll put out at the end, an ID, a unique ID for every data set, and this is actually the technical development I think that we're going to have to solve this problem. So iDash is at UCSD. It's developed by health researchers, and they have a long list of health data sets that they already have online, and there's some really exciting stuff going on there. So we finally did publish this paper in 2006, Reproducible Research, moving towards research the public can really trust, and we proposed the following thing, that there's be a reproducible research statement at the end. Now, we talked a lot about what we wanted to require. In the end, we really could require nothing. The only thing we could require was a statement, is whether the study protocol will be available and how, whether the code will be available, and whether the data set will be available and how to get it. A couple things about that. Why did we just say, this is about as weak as you can get? Now, why? And this is a key to the issue of what the solution is. It's because if Annals of Internal Medicine starts putting up big barriers saying you must do what you don't want to do, well, what's the quickest thing you're going to do? You publish somewhere else. So, journals are competitive with each other. They also want to publish the best stuff. And they can't put up barriers that nobody else is putting up. So we felt that this would at least shine a light on this and make the statement public. But, like warning labels on cigarettes, people get used to this, and they gradually are not too embarrassed by saying things will not be available. And that's a big problem. One thing about the protocols, I'll tell a little anecdote. One of my favorite is a group that we, couldn't figure out what they're doing, couldn't figure out. So finally, we asked for the protocol. We waited for the paper. Like 5 months later, we write to them, say, what's going on? Where's the protocol? He said, oh, don't worry, we're still writing it. So this is a reproducible research statement. And this was brought here's another one, and this represents one of the problems you'll see. And this is very, very typical. Study protocol and statistical code available from Dr. McWilliams. Now, what you don't know is what happens when you actually write to the person. I'll talk about that in a second. But what they've said is, what about the data set? They direct you to N. Haynes. And that's often what we get. So they don't give you the analytic data set they use for this particular study, and this does not help you very much. We did a look back. This is actually done a few years ago at 2 years of this, and about over 80% said the protocol was available, 70% said the code, and 60% said the data were available. And we're actually in the process of the editors and staff there of doing a much longer follow-up. This is like from 2008 or 2009. We also looked what happened. We emailed the authors and asked them, were people asking for these things? And, about, maybe 5 to 10% said that they were getting some requests. We do that with 100% of our authors now, but we're trying to think about how we can really find out what the experience of requesting these things are. But the uptake is not huge. I mean, for the most part, they tell me their impression from the canvassing is that not a lot of folks are getting the requests. Now, this is a very comprehensive list of what's going on at all the journals, and I'll just highlight a few. And up at the top, I have, do they require that the code be shared publicly? By the way, on this issue of code, one of the issues of, blowing the top off science, there are a non-trivial number of contributors who don't know what code is. I mean, they point and click, they use Excel, who knows what they use. But when you ask for statistical code, they literally don't know what you're talking about. So this is, again, a problem and shows how even asking the question can be revelatory. So New England, background for this. So one of the first things that the Annals did after they instituted this, they're part of the ICMJE, the International Committee of Medical Journal Editors, and brought this up and said, is this something we can all agree on? And without going into further detail, the answer was no. And it was voted down that year, and it was taken off the agenda for discussion this year. And so it's not a subject of discussion there at the moment, and journals are basically deciding on their own what to do. So New England Journal, as far as we could tell, they have no requirements, although I was just told that they actually are now, for the past year, always posting protocols, and I'll show you that in a second. JAMA, nothing. except they do require the somewhat controversial and an independent academic statistician to corroborate analyses of industry-funded studies. This does not mean, by the way, that they might not occasionally publish protocols or whatever in the supplementary materials, but we could find absolutely nothing on the website or in articles that showed. Now, they led the way in issues of how to report author contributions and things like that. So it's not that they're doing nothing in this area, but they've they've approached it in other ways. The Annals and BMJ actually picked up exactly our model, and they require the author to state whether these things are available. The Lancet, we couldn't find a policy identified. Biostatistics, the journal, has a very interesting thing, which is they have a full-time reproducibility research editor, who's actually the first author, Roger Pang, on that epidemiology piece, who will actually rerun the data if submitted that way, and they will mark with a big mark on the paper, D if the data was provided, C if the code was provided, and R if it was proven to be reproducible. Exciting idea, but it takes a dedicated resources and a dedicated editor to do this. No small thing, and not something that we can expect journals to be doing in general. PLOS Medicine has a very comprehensive policy. I don't have time to read all through this, but one wonders exactly how it's working in practice. But it is by far the most comprehensive written policy that we have. This is an example of the kite mark up here. This is the code, and it's very, very prominent. And something like that. We thought of doing that at Annals, but didn't quite think of this. It was like one thumb up for for one thing, 2, 3, and then we thought, well, maybe asterisk. Okay, no, teddy bears, whatever. It did. We couldn't get away from the idea that the authors will feel that they were being judged, and it would look bad. So we couldn't do this. And interesting, they use a sort of categorical rating system. It's not A, B, C. It's just DCR indicating what folks are providing. So I went to the New England Journal website to see how this protocol thing was working, because I could find nothing in instructions for authors about the protocol. So this is last night. This is what you'll see if you go to the website today. And so here's a nice clinical trial. And so I went to the supplementary materials, and there it was. It was just in supplementary materials. It didn't say protocol, but when you clicked on that, you saw this. The trial protocol has been provided by the authors to give into additional information about their work, and here it is. Oops. Dr. Eichler, I don't know. Is this something you could help us with? So what did I go to? I went to Google Translate, and this is what I get. So you can read through that. The previously durchgeführten. Okay, so how these things work in practice and how they work on paper are sometimes two very different things. The letter of the law, they absolutely adhere to it. Now, what's also interesting is that in the hard sciences and in basic science, this is a well-established approach, and there's much more of a culture and regulations about data sharing and putting genome sequences and genomic data into databases, and they've reaped a huge amount of benefit from that. But it's a different culture, different regulations, and I would submit a different set of considerations, but we have a lot to learn from that because anyway, so Nature, Science, and PNAS all have quite detailed descriptions and requirements for data deposition. So I'm not going to go through this. This is the proposal from Science, which basically says, put data into the public repository, and all the different ways to handle this, the code, et cetera. So what should journals do and what can they do? Well, we've already seen an example of what they can do. Clinical trial registration. This is, a collective statement by all the journals. Here are the editors from all the journals, and we know how that's worked. Well, why has that worked so well, even though it's certainly in need of improvement? Why was this successful? Well, there was a central repository, only one place. The proposals that the journals house some of this stuff, it doesn't work, because what you're going to get is different protocols, different data sets, all sorts of different things in different places. That's even if they had the technical capacity to do it. You have to develop some sort of curation or whatever. It's a mess. So this is not going to work on a journal by journal basis. And the vast majority of journals are run out of the hip pockets of societies or individuals. They do not have the resources to do this. So we need a central repository. It's very helpful to have a legislative mandate for actually doing what you're doing. And of course, with clinicaltrials.gov, it's not for everything, but it's for an important subset. And this got the ball rolling. And it was used, it's used by many folks for which it's not absolutely required. Really, it was the journals that put the final, I don't want to say, the final nail in the, well, what's the right metaphor? Yeah. And this was a form of journal collective action, which we are not remotely getting in the data sharing realm. And of course, it also required Deb Zarin. So it requires people, structures, and laws. What can they not do? They can't be effective acting alone. They can't be the custodians of the research data. They can't afford staff just for this purpose, and they can't be the sole guarantors of scientific quality. What are the funder policies? I'm actually going to leave this to the speaker behind me. But of course, we have the Shelby Amendment, which says you can FOIA any research used for public policy. NIH says you have to have a data sharing plan for high ticket research, but whether this is being honored in the breach, I suspect it is. I don't think we're getting a huge amount of yield from this, and whatever they're getting, I don't know how much it's being used, and we'll maybe hear about that. Interesting, NHLBI requires, and it's not quite the same as the NIH, the deposit into BioLink 2 years after publication, 3 years after the end of follow-up. Again, I don't know exactly what the status of that is. ARC and VA, we couldn't find any specific plans, and NSF just started that you're required to have data sharing plans. Interesting, Howard Hughes has a very detailed data sharing requirement, and it adds these other requirements that as a function of sharing, you can insist on collaboration, that you can require the recipients of the materials to pay for the cost, should include all the data, and provide the executable code and file and source code. Interestingly, all the funders on this list got together earlier this year to try to tackle this problem. And they published a statement, I don't know how many of you read it, that was published in Lancet. And what did the statement say? Here's what it looks like. It was published in January. And I'm not going to read through it, but I'll just summarize it, which is just say, this is a really hard problem and we're all going to work to solve it. So, it's an important first step, but they acknowledge what's important when you read through this. They acknowledge the real interests on both sides, that this isn't just a cultural behavioral problem. It is a community scientific incentive problem that we're going to actually have to work hard to solve. And here is one proposal to solve it. Oh, so how do you solve collective action problems? I don't know how many of you have seen this. These are guys looking at mice dressed a lot like us, and mice are not known necessarily for their cooperation, and this is what they're saying. Okay, now let's slowly lower in the grant money. That's how you get collective action. You align the incentives. So here would be one incentive, and it's a sort of slightly more it's the operational version of what Andrew just said. Currently, there are just two ways to use publications to measure academic success. Either are you on the paper or is the paper cited? That's pretty much it. And there have been lots and lots of metrics sort of built on these, the H factor, the impact factor for journals. Journals themselves are measured. What we need is something measurable, and it's unbelievable what happens when you start to measure things. We need a third measure, which is a marker for the use of the data, for original research published by others. And we can't do this unless we actually develop some sort of unique identifier for each data set. So just like a PubMed ID for the paper, we need the same ID for the data set. And every single time that data set is used, it needs to be put in the paper that uses it, and you can easily go and retrieve and the use of the data. And just imagine if you had not just the citations to the original paper, but every time it appeared, because those papers are diffuse. So every time it was used, even by a meta-analyst, that gets reported, and then that goes on the CV, the academic researcher. Now, this is actually being worked on by the folks at iDash, so this is not a completely new idea, and I think there are other folks as well. But I think it's absolutely key to solving this problem. Just hammering people over the head and saying you're behaving wrong, you're believing wrong, you're acting wrong is not going to do it when there's a whole host of incentives and that go the other way, which is very much also, they would say, about scientific quality and scientific yield, because they know their data best. They construct large teams that are built on the idea that these can be mined, and there's a whole academic superstructure built on the idea that if you put in a lot of work, you're going to be able to reap the benefits of that, and society, and it's not just themselves individually, for many years. So we have to create a culture and a reality where people benefit as much from everyone sharing their data for all purposes as they currently do from protecting it. So with that, I will stop, and I apologize for being over time.